welcome to everybody, and thank you for joining us in our last SoDa Symposium for this semester. We welcome you here to this special one, which is a Social Data Science Center Seed Grant Symposium. It's a series that we started to hear the results and hear the ongoing work of our seed grants recipients. We will have the presentation today, followed by a discussion, and then there's time for questions and answers afterwards. On the bottom of the Zoom window, you see the Q&A feature. And please, at any time during the symposium, write in your questions. You're not interrupting. It is nicely tucked away here. And then we will return to those questions in the Q&A session. With me, helping to moderate this is Kara Hinch, who is an adjunct assistant professor here with us in Maryland, but also at the University of Munich. So our speakers today will be Phil Resnik. He's a SoDa Seed Grant Award recipient, but more importantly, he is professor at the University of Maryland in the Department of Linguistics in the Institute for Advanced Computer Studies. He earned his bachelor in computer science at Harvard and his PhD in computer and information science at the University of Pennsylvania. And all his research is around computational linguistics. Prior to joining UMD, he was an associate scientist at BBN, a graduate summer intern at IBM Watson Research Center, while at UPenn, and also a research scientist at Sun Microsystems Laboratories. So you can see, you know, he has always had this industry link and engaged in that. In 2020, he was designated a fellow of the Association of Computational Linguistics. His most recent research works focus on the combination of cognitive neuroscience and language, where he's using computational modeling in connection with brain imaging, looks at the role of context and predictive processing during online language comprehension, and many more of these topics. I'm personally excited about his work on language use, exploring the underlying mental state of people, but more on that some other time. With us here is Alexander Hoyle. He is a PhD candidate working at the University of Maryland's Computational Linguistics and Information Processing Lab and is advised by Phil Resnik. Hoyle's research is oriented around the development and evaluation of methods for computational social science. He also had a number of interesting internships. One was at the FATE group at Microsoft Research and AI and NLP at AI too. Hoyle received a master's in computational statistics and machine learning at University College London. Prior to graduate school, Hoyle was a research analyst at the Brattle Group in Cambridge, Massachusetts, and helped conduct research in New York City public housing for the US Department of Justice. And excited to introduce to you our industry expert who will provide today's commentary. Andrew Stavisky is an assistant director in the Applied Research and Methods Group at the US Government Accountability Office, the nonpartisan independent investigative arm of Congress, where he advises on policy research and leads GAO qualitative research practice. His policy areas focus on national security, cybersecurity, telecommunication, and other emerging technologies, which now, of course, has made him one of the agency's leaders on AI policy. And if you happen to be at APO this year, he's hosting an idea group on Tuesday, so come join us there if you like what's happening here today. Andrew collaborates with GAO Innovation Lab and develops use cases for its internal generative AI and topic modeling platform. So he's a perfect commentary here for our session. So I already took up too much time with all the intros, but I'm excited to have you guys here, and I'll turn the floor over to you, Philip.
Fantastic. I'll try to make up a little bit of time. So first, I just want to say thank you, Frauke, to you and all of SoDa for the invitation and for the support. Really appreciate it. I also want to thank Andrew for being here. He is, as you mentioned, just a perfect fit for somebody to be talking about this stuff. So I'd like to begin simply by setting up the problem. There is something going on day to day in qualitative research, a process of figuring out what categories, what constructs occur in samples of text that is very rigorous and also very, very labor intensive. Back to the traditional, you read all of the things, say these are transcript terms or open-ended responses, and you figure out what kinds of categories you're seeing, you try to firm those up, you discuss them, you check reliability and so forth. This is quite a process, right? This is just a figure from a practical guide to this stuff, and pretty much every one of these stages requires a great deal of human effort. So it's an important process that gives you a rigorous conception of what the constructs are within a particular collection of text, but it's very, very hard to scale up. I got interested in this because of open-ended responses, and for some discussion of that and some earlier work that I'll touch on very briefly here, I'll refer you back to the recording of the SoDa Symposium there. Now, let's look at what the computational people do. This is the world I come from. We tend to have scalability, but without the rigor. So what do I mean by that? This is the Wikipedia page on Plutchik's theory of emotion. Say we've got emotion as a construct, or the individual emotions as constructs that we care about. This is just the beginning of pages and pages and pages of discussion, and there's a zillion papers discussing this stuff. And when it comes to computer scientists working on this, this is pretty much what it looks like, right? We just have a set of labels without a great deal of thought as to what they mean. And in fact, it is not uncommon in the literature to have proxies for these things without any kind of coding or annotation at all. Like, hey, we need instances of text containing anger. Let's look for hashtag mad or hashtag pissed. And so this is very scalable, right? You can get lots of data this way, or annotating data manually, right? One can do that also. I used to use the terms annotation in computational work and coding in the social sciences and say they were interchangeable, but I'm now not, I just don't think that's true anymore. I think coding has the kind of rigor that we're talking about here, and I want to reserve the word annotation. I want to keep these things apart for what is much more typically done in the computational work, which tends not to be more rigorous, even if it's being done by hand. For example, doing this with anonymous crowdsources on Mechanical Turk. Now, these computational methods are that way, at least in part because there's too little interaction between the computational people and the people with the real questions and problems, say in this case, the social scientists. Theory is secondary, and the idea of like, are these constructs meaningful? Are they measuring what we want them to? Is actually really quite rare in this discussion, although here's a footnote for some other work that we don't have time to discuss that I think is good pointers. People care about the technology. They care about the methods and the connection to the real problems and the ways that social scientists look at things, the idea of a construct. If you ask most computer scientists what a construct is, they're not going to have an answer for you. We deal in labels. Maybe we call them categories. Now, there's a question, can large language models help you get to scalability with rigor, the two together? Now, before we go there, I feel as if we need to give people a sense of what large language models actually do. Here is a primer on the most important thing that you need to know about large language models. Large language models, like all language models, an idea that goes back at least 50 years, possibly back to Markov in 1913. All language models have the job. What defines them is basically the job of predicting the next word. They deal in probabilities of strings, and they use those probabilities to predict a probable next word, period. A plausible next word given the context. If you want to understand this, right, there's a children's kind of collaborative storytelling game that's kind of fun. Do it with your kids if you haven't already. You give them a start to the story, like say, once upon a time, there was a pretty unicorn, and then they go in a circle contributing one word at a time. So I might point to one of these kids and say, okay, now you. And she'll say, she, right? Continuing the story. Once upon a time, there was a pretty unicorn, she. And the next kid liked to dance in the moonlight, and then it continues. And this is the way you generate a story. I call it a circle story. You give them the stuff in green here, which for present and future purposes in the talk, we'll call the prompt, right? The thing that you're getting the response in response to. And then you generate this one word at a time on the basis of what's plausible. Now, here's an issue. Plausible and true are two different things, as a lawyer named Stephen Schwartz found out, much to his chagrin. He and a colleague used ChatGPT to create a legal brief that they filed in court. They got in some serious trouble for this. And the crucial thing here is in his affidavit, he said the citations and opinions in question were provided by ChatGPT, and he's apologizing for using this tool, which also provided its legal source and assured the reliability of its content. Notice how much anthropomorphism there is here, right? It provided its legal source, and just as if somebody went and looked stuff up, it gave assurances of reliability like a person would, except it's not like a person would. You can actually go and look at this affidavit, which includes the conversation with ChatGPT. After doing this stuff, apparently, he said, is Varghese a real case? Now, you should right now be thinking about the circle story, right? Replace ChatGPT with these kids. What is a plausible, if you've seen gajillion words of text, and you said, what is a plausible next word? Well, one very plausible next word is yes. It's a very plausible word to follow in that context. If I were writing a story, that might be the next word that I chose. What might I choose after the comma in this, after the yes in this context? I might put a comma. That's a natural thing to do. Varghese versus, et cetera, et cetera. ChatGPT generated a response, this supposed assurance, word by word, just like the kids in the circle story. Okay, that's super important. So there's what it said. And then he went on to ask, are the other cases you provided? I'll leave it as an exercise. Now think about what the plausible word by word response is. I'll give you a hint. The next word is no, right? It generated this response one word at a time. So the thing you need to remember about large language models is their job is to predict the next word based on context. And as a good first approximation, that is their only job. Everything you see, whether it's the answer to a multiple choice question or a supposed explanation of their reasoning, is simply being generated one little piece at a time without any reference to a database, to a model of truth. This is how these things work. Now, plausible often is right. I mean, things that are plausible are often also correct, but that is a side effect, a very useful side effect, but a side effect, okay? In the remainder of the talk, we're going to talk about trying to use these things in the social sciences with a focus on, well, figuring out what the constructs are and then operationalizing them for measurement. I want to start very briefly, one slide's worth, on what I talked about at the SoDa talk that I gave some time ago, where we didn't use large language models. We used another existing technology that was there before that called topic models that some of you may have seen, which basically does not generate word by word by word. It does an analysis, and you can think of it very loosely as a kind of clustering. Discover useful clusters of words that characterize the topics that show up in this collection. If in a survey, open-ended responses asking about concerns about the COVID pandemic, something we did collaborating with Westat, you can see, for example, at topic 9 here, you read it, and as a human being, you can see, it seems to be about long-term health effects, and you can actually read the verbatims that the model ranks as most connected with this topic, and it's like, yeah, it's doing a pretty good job here. But look, a set of words is not a code. And so what we did was develop a rigorous protocol that involved human beings as a post-process to independent code set developers, right? Using a topic-driven approach to coming up with this. So they didn't read all of the verbatims. They simply read the ones up to a point with a limit of time that were most related to get their characterization of what this topic described. They did this independently, And then we triangulate. You have a consensus coding process that might say, okay, these are a little bit different. Here is what we think is the real code that we should take from this. A topic model driven coding process. Now, one of the interesting things about this is we discover that if you actually look at independent developed coding schemes, humans do not agree with each other all the time. In fact, they disagree. People look at intercoder reliability a lot, but they don't look at intercode set reliability. And what we're finding is that there is a lot of similarity between the independently created code books, but this automated plus human process doesn't do a terrible job in this preliminary work matching that. Okay, so I'm just going to take another couple of minutes to tell you about an approach that we've been taking using large language models. And it is its core focus is the idea that what's in the visible text is not all there is. So if you hear somebody say, build the wall, one can plausibly infer, plausible, that's something that these models are good at, right? Propositions like this person believes there should be a wall on the US-Mexico border, or illegal immigration is bad, et cetera, et cetera. Can we use large language models to surface the implicit content, right? We call these inferential, because we're inferring them, decompositions, because they're pieces of underlying content that we are pulling out. Can we get the language model to do that? I'm not going to go through this in great detail, but the idea is, yes, we create carefully crafted prompts that will be used by the language model, telling it to propose plausible underlying implicit propositions. We then confirm that some of these, or that these in general are plausible with human confirmation, so validity of the approach in that sense, and then use that in some downstream task using these inferential decompositions language as if they were language. It turns out it does a very good job of proposing plausible stuff. And if you apply this to a big set of text, in this case, tens of thousands of FDA request for comments responses on emergency authorization of COVID vaccines, not only does it do a very good job of proposing things that are connected with what people said explicitly, right? In this case, we can look at this and see, some sense of vaccine hesitancy, right? But in addition, right, when you take these bits of language and use them just as you would with other forms of natural language processing, which I'm not going to go into detail, if you then cluster these things as if you were clustering just language that people produced, when you compare this with other ways of clustering, combining, trying to find categories, this works better, right? You get tighter, more coherent clusters that have a higher quality according to the usual ways of evaluating cluster quality. These things align with things that other people have found analyzing similar data. And they're easier to read, easier to distinguish these things because they're short, they're concise, right? So the takeaway here is that by going from explicit to explicit plus implicit language, you can then apply the full arsenal of natural language processing to the things that are behind what people said, which is really what you care about, not just what they actually said. And with this, I'm going to turn it over to Alexander for the remainder of the talk.
Thank you. Sorry, and I'm taking over. I hope everybody can see it. Okay. Yeah, so we've sort of talked about this construct discovery up till now, right? But the second half of the title of the talk is about measurement, right? And I think it's very tempting to say, okay, I want to measure whether these tweets or these texts are discussing, are exemplifying things like vaccine hesitancy, are instantiations of this construct of, say, vaccine hesitancy, or that they're polarized, or they're more conservative or more liberal or something like that, right? And there's at this point this kind of cottage industry of papers saying, well, we take some data, we take the construct we care about, and we code the data with ChatGPT or some large language model. And I think this can be done effectively. I mean, this has been done effectively in the pre-ChatGPT era, where you would have some data, you would maybe hand code it with experts who'd confirm that your supervised or NLP approach was able to reliably sort of do the coding, you know, to within a reasonable degree of accuracy, and then you could use that to sort of code additional data that was still in the same kind of sample space, and be relatively satisfied that those codes were also accurate. And I think that paradigm still makes sense, but it's also tempting to say, well, okay, these language models seem to have robust understandings of constructs, so I'm going to, you know, code these texts for vaccine hesitancy or xenophobia or whatever it is that you want to measure. But it's really crucial to know that just because it seems that a model produces a cogent definition, for example, of the construct you care about, you say, okay, give me a definition of this construct. It provides it's reasonable. That doesn't mean that when it's identifying that construct in the real world that it's going to do so reliably. And it may give an explanation that, again, appears correct, but the explanation, again, doesn't necessarily have any bearing on the correctness of what the model is doing. And we had some slides on this that we've cut for time, but we can get back to them at the end. So the idea here is, well, they're still useful, right? We still want to do measurement rigorously and reliably at scale. So the project that's ongoing that we've been working on is sort of adapting the standard measurement process in the social sciences for use with language models. And I think as I'm talking about this, the idea is that these language models are more of a partner in the measurement process rather than sort of the only thing doing the measurement. And we've been working on this construct called suicide crisis syndrome, which is this condition associated with imminent suicidal behavior. It's different from something like suicidal ideation. It's really about this imminent risk. And right, in the social sciences, including psychological sciences, a lot of constructs are operationalized by different sort of sub-criteria that may be easier to identify, right? In content analysis, the structure is often represented by a code book. In the psychiatry, you'll have things, something like clinical depression and the DSM that's perhaps broken up into different diagnostic criteria. And well, this isn't always the case. Usually in NLP, you're only focusing on sort of the classification of the high-level construct alone, and that can make the process harder to interpret. And again, a large language model can give you some explanation in scare quotes of its coding decision, but there's no guarantee that that explanation is really a faithful representation of its reasoning process, or that it follows what human users would consider to be valid reasoning steps, what an expert would consider to be valid reasoning steps. So our idea here is to construct a sort of human AI framework for verifiable and interpretable construct annotation. And to take a step back here, talk about maybe a more traditional approach for learning rules, you'll have decision trees, right? And decision trees are this really well-established interpretable machine learning method. They're at this point, that's 40 years old, sorry. And decision trees operate sort of over known features. And to talk about what common features are when we're dealing with text, well, you'll start with, say, some data here. These are let's imagine tweets from legislators in the US. And you'll identify the words that exist in those tweets, or maybe pairs of words, and you can code each tweet by sort of the words that appeared in it in this kind of binary fashion, right? And once you've done that, you can say, okay, for a particular feature, here a feature would be the presence of a word. We can use that feature to help split up our data. And what I mean by that is that you're trying to maximize sort of if here, say we're trying to identify the party of the speaker, Republican or Democrat. We'll pretend that we're only dealing with this with the two parties. And we want to identify which features are helpful for splitting up the data so that when we split the data, it's at each split, the data is pure, that we have sort of more Republicans on one side and maybe more Democrats on the other side. So to give an example of this, if we use a word like the to split up the data, so we divide all the texts that either contain or do not contain the word the, that's probably not going to be very effective. And we'll end up with sort of even numbers of Republican and Democrat texts that contain the word the, and even numbers that don't. And you may not even have that very many in this bucket to begin with. But maybe we have a word like Obamacare, right? Where typically, if someone's saying the word Obamacare, it's often in a more pejorative sense, and they're more likely to be Republican, and they're disparaging it, right? Whereas if they're not using it, maybe that's not that informative one way or the other. And again, the idea here is we're trying to maximize this purity. So when you're training a decision tree, the idea is you're building up these sort of this tree of rules, these binary rules that can be used to identify whether new data is in sort of one class or the other. So you'll start with this Obamacare, and then maybe you'll break everything that falls up into this one branch, all the data that falls up into this one branch along the lines of affordable. And on the left-hand side, maybe, I don't know, the word that comes up is family, and you sort of iterate that way. And what we're doing here, one issue with this process, right, is that individual words like this maybe aren't that interpretable. They aren't that sensible. And what we're trying to do is figure out a way of flexibly identifying these features in such a way that the features themselves are more interpretable to people. And we're just doing preliminary experiments right now where we're classifying contentious articles on Wikipedia. So the idea is we'll start with some labeled data and maybe some definition of what we think contentious means, but this is optional. And then you'll prompt a large language model saying, okay, here's some examples of contentious articles, here's some examples of articles that are more benign, and propose some rules, some ways of dividing up that data that distinguishes the contentious articles from the articles that aren't contentious. So here it might say, okay, well, the topic of the article relates to a conflict, maybe it concerns a racial or ethnic group, articles about a historical event, fairly high level. But the idea is that these rules are verifiable, they're easy, and that we can trust that when a language model or an automated process has identified the rule, that it's correct. So the way we do that is you evaluate, you sort of ask either a large language model or a different kind of classifier to classify documents according to this rule. And then you'll have your human user say, okay, let me check myself. I'm going to see if I agree with the language model on some subset of the data. And if people agree with the language model to a very high degree, then we say, okay, that's a good rule. This is a reasonably, we can trust that when the language model is applying this rule, that it's doing so in a consistent way. But some rules maybe aren't applied as consistently, and we'll drop them. We disagree with what the model is doing. And the idea is you collect a pool of these, and treat them as binary features, you can then train something like a decision tree, right? So it functions more or less in exactly the same way. You'll have your positive and negative documents here. They'll get coded for a variety of these rules, and then you can learn a decision tree over them. So in some super early experiments, this seems to work pretty well. So for this contentious article case, here's what the standard baseline is doing, where you're just looking at words or pairs of words called bigrams to divide up the data. And right, okay, the first high-level rule here is Palestinian. So if Palestinians in the document, it's likely to be contentious. That makes sense. We can sort of interpret that reasonably well. But as soon as you start breaking it up, things get a little less clear. The next rule is scale 10. No idea what that means. And then you go further down and it says mice. Okay, what's really going on here? How, if a human were trying to apply this, you could do it, but they wouldn't necessarily have any intuition about why they were doing it. It may not be that reliable. And it can get quite complex quickly. In our setup, where you sort of define these nice, reliable rules in advance, you get a much cleaner picture, right? First, okay, does the text talk about a historical or contemporary political event or figure? This is a little broad, but it helps cut out things like episodes of The Simpsons. And then we'll break it up further, right? You get down here. Okay, does the text involve a location or entity in the Middle East, right? Again, quite sensible. There's some repetitions here because of like some issues we're still ironing out, but like it does work. And what's interesting is when you do this, and again, this is super preliminary, we haven't really tuned anything. Our methods more or less just is accurate as this bigram baseline. But the depth of the tree here I'm collapsing it at the bottom. But if you expanded this out, the depth of the tree for the bigrams is an order of magnitude more than for the rules. It's just a far more complex process for identifying this. And in sort of the next steps, we're going to be applying this to sort of substantive constructs that we really care about, like suicide crisis syndrome or entrapment, which is one of the indicators of suicide crisis syndrome. We're going to be looking at some human validation, doing some user studies to understand if sort of people agree with what the models are doing. And yeah, I want to be respectful of time. I don't know exactly, have a sense of how far we are along, but I'm not getting any pings. So
we should wrap up.
Yeah, to wrap up, takeaway is that we can't assume that large language models are trustworthy, but if we're using them sort of carefully and we've done sort of sufficient validation, and really validation's the name of the game here, then we can maybe do some analyses that are more rigorous and scalable. And yeah, now we're, I think, into the discussion period.
Thank you so much, Alexander and Philip, for this insightful presentation. And Andrew, thank you, our industry expert. You are here to do the transition to the discussion section, providing a first set of comments on the presentation. Andrew, the Zoom room is now yours.
Thank you, Carol. Yeah, I just really enjoyed the presentation, and thanks for having me serve as the discussion. So really, I see my role here as sort of the proxy for the intended audience, right? End users of what's going to happen with this work. I mean, I'm not in any way an academic. I'm a social scientist. I'm a practitioner, an end user of these kind of methods. And so as a practitioner, I want to underscore like how important these developments are that Alex and Professor Resnik are working on and have presented. It's not trivial. These are really important real world applications that they're working on. So that's the perspective that I'm coming from. What I want to just also start from, just to put this in a little bit more perspective, is just talk about what we're doing at GAO from the practitioner side, and hopefully that'll transition into some of these applications. And so we're exploring many use cases for analyzing unstructured data, right? It could be, and some of the things they've talked about, right? It could be understanding public comments, being able to quickly search and summarize prior work. Since we're part of Congress, like we do a lot of work on comparing various bills or proposed bills and using this kind of analysis to figure that out, to summarize, to see how those are different, right? For me, as a methodologist, as a qualitative researcher, the holy grail of use cases for me in all this, and which I've been exploring, is using that NLP, machine-assisted content analysis, for either analyzing survey open ends, which was the use case that Philip talked about with his TopCat presentation, and also for things like focus group transcripts or interview transcripts, right? So there's a lot of use cases for what these guys are working on. And at GAO, we're in the process of, I know Philip didn't talk much about TopCat. That's what I'm most familiar with. I will spend a few minutes talking about that as sort of also helping transition into some of the other stuff that was presented. But we're actually in the process of testing both a TopCat version of topic modeling and also the use of LLMs, both as like a sole tool for analysis and also as the second step in the TopCat process. So instead of, as Philip talked about, where you have the humans that are taking that second step and coming together independently and then building a consensus model of what those categories are, this would be using the large language model essentially instead, right, to do that analysis. And then the humans, which I feel and preach to anyone that'll listen, should always be in the loop of any of these methods. The humans would be more of a quality control and interpretive role. And so just also one more little sort of piece of information that I think is useful. So at GAO, we publish hundreds of congressional reports every year. We're, as Frauke mentioned, we're an independent, nonpartisan, non-political part of the legislative branch, which is Congress. So we're always in our reports saying things that make whoever we're writing about upset. Typically, we're making recommendations, we're talking about how things can be improved. And so from an agenda perspective, we're pretty bulletproof, right? I mean, we don't have an agenda, we're nonpartisan and independent. So what comes next is the methodologies that have to be pretty rock solid. And so when we're incorporating like an unstructured text analysis into our reports, and we do that a lot, when we're using NLP now, and where it's important to analyze like a large corpus of data as efficiently as possible, right? Philip talked about this, right? You need to maintain rigor, but it's that trust and explainability piece for us that's most important. So that's why this stuff is so exciting. I just want to give a few high-level thoughts on some of this and then have a couple starter questions, and then I'll just turn it over to the Q&A. So I do want to talk about TopCat just a little bit more. I know this wasn't the focus of the presentation, but as we begin to explore NLP solutions at GAO, right, this idea of, and I think Philip mentioned this too, this inductive approach, right, which bypasses researcher bias and sort of mitigates the top-down approach to doing this kind of analysis. It's really important. But what we learned early on was that traditional topic modeling using LDA is insufficient. And it's really, it needs a human expertise. It needs that human piece of it. And so Philip didn't mention it here, but he talks about this idea of a curated human in the loop step. And that's really what's needed for the topic modeling, right? You have to have that human in the loop process. And so the idea of having that protocol for human in the loop using topic modeling as a starting point to build the code frame, right? And having that trustability, right? That solves most of the issues with the topic modeling. And I really love this idea. I can't wait to test it at GAO. And what I would, I guess my question sort of on TopCat that also applies to the other parts of the presentation is, what, if any, lessons from the work that you're doing now on inferential decompositions, right? And then the piece that Alex talked about on that human LLM partnership using the decision tree piece, right? How do you apply that, if you can, to topic modeling to improve the TopCat process, right? So that's one question. I like this idea on the inferential decompositions, and I'm trying to go fast here too, so I apologize. But of incorporating both implicit and explicit content into NLP. I think that's an insightful advancement for a practitioner like me. It looks incredibly promising, something that I never would have thought about, so I really appreciate that. And I understand the point that even interpreting topic models can be labor intensive, right, because of both explicit and implicit content. And I hadn't really thought about that either. And so I'm always interested in seeing how we can make that process more efficient and more trustable, right? That's the win-win. And so this idea of getting better clusters that are easy to read, of course, that's also a really great development. What I want to know here is, and maybe I just missed it or just didn't understand it enough, but what does it take, right, in terms of what was presented primarily on the inferential decomposition piece? Like, how would I apply that to, these GAO content analysis work, right? As I'm this proxy for the end users on content analysis, like that's how I think about it. And the other piece is I was able to see a larger version of the slides, and Alex mentioned that some of those got cut, but there was a slide that talked about this 5-step process that sort of walked through like what the process is that they're going through in terms of putting this actually into practice. And as an end user, is it that full process that you had laid out? And maybe that's something you can talk about too, that the end user would need to use, or is there a simpler process that someone like me would use and incorporate? And then just a little bit more on the decision tree piece. And again, my lens are through the, my comments are through the lens of a practitioner and a social scientist, not as a computer scientist, not a computational linguist. But I really did like a lot of the stuff, right? Particularly, and Alex alluded to this, but didn't really talk about it as much as I thought, which was this idea of the human and the LLM process, right? So with the TopCat, that's the key, right? It's the human and the topic modeling. And so with this, what I was taking out of it too was, it's a human and LLM process, and maybe just a little bit more on how that works and how the human piece, how that partnership works. I feel like I could understand that a little bit more. Maybe there's one other question, just for sake of time. Yeah, it's just really about how do we go from using these processes for model training and development to this end use application? And how does someone like me begin to implement some of these techniques into my workflow of analyzing unstructured data? I think I'll leave it there. I'd love to hear what comes next. I thought this was so great, and I wish I fully understood more of it. I feel like, but I love it. I love this human LLM partnership idea, and I'll just leave it there and happy to hear more. And I hope that made a little bit of sense.
Caro, do you or somebody, do you want to moderate since we have a bunch of questions? Why don't you just, tell us what it is that we should answer?
Yes. So if you want to first answer to Andrew's comments, I think that would be great. And Alexander has already answered some of the questions that are now rolling in the Q&A. So thank you for that. So maybe Philip, you take a first go at Andrew's comments, and then we can tackle some of these other very interesting questions.
Absolutely. And Andrew, thank you so much for taking the time to look at it and understand. And I'm looking forward to talking with you about this stuff, further on. So there were a couple of questions that you raised. One had to do, and there's a similar theme actually, I think, in the response. One question you asked was, could this the insights from the large language modeling stuff actually be applied to, and I'm thinking in some kind of hybrid way, some of the insights, right? You've got the topic modeling with curation, you've got the LLM stuff. Is there a hybrid that takes, that puts together these things, or, learn from the features of these things, what's good in order to improve one or the other or both? Another question that you asked had to do with the inferential decompositions and sort of that, and the decision tree stuff, and how that fit in with the human stuff. I think there's a general theme here, right? Which is the idea of thinking about what a human would do, right? And then either having the human do it, if it can be done sufficiently reliably. I'm sorry, having the LLM do it. There's kind of points on a scale. You can't trust the machine at all, or it's not useful. The human has to do it. At another extreme, the machine is so reliable that all the human needs to do is verify. And then in the middle, there's an interleaving of some kind, right? Now with TopCat, what we found is that the topic modeling, when it's done carefully, you can actually get to the point where much of the time in the test cases that we've looked at, automatic topic modeling, right, with a little human feedback to say roughly how many categories do we expect to have, is enough to get a good starting point topic model, and then the humans can take over, right? So there's a question there in what the humans are doing when they're taking over. Could we substitute in a large language model in place of one or the other human, right? I'd be cautious about both. This reminds me of what Educational Testing Service did years ago. They used to have 3 people grade the essays on these standardized tests. Then what they did was they had one, or maybe it was 2 people, 2 human beings, always. And then what they did is they said, we're going to have the machine automatically do it. And if it agrees with a human, then we don't bother with the second human. And so for a lot of that process, right, they don't need 2 people. On average, they need 1 point something human beings looking at each essay, right? And so one can imagine similar places here where you're interleaving these things. The second general comment is particularly with the inferential decompositions. We have a general theme where if you can represent stuff as language, then you can use it downstream for whatever you want in NLP stuff. I refer to sort of the full arsenal of NLP. So if you use the large language model to give you these inferential, kind of what's going on underneath the text, or other aspects of things like happen in the decision tree process, right? Like instead of having predefined features, we're using the LLM to define features from a potentially infinite space of features. But once you've done that, what do we pipe it to at the moment? Straight up decision tree learning that's been around since the 1980s. Familiar, reliable, we know how those techniques work. So the idea is not humans do it, oh, let's now have LLMs do it, which is what a lot of people are doing, right? It's where can the LLMs provide a human-like contribution? How do we determine that it's reliable enough, right? Possibly by validating, possibly by keeping a human in the loop in some way, and then how do we pass that on downstream to other processes? So that was a long-winded response, but it was an attempt at covering sort of most of the gamut of what you're talking about, Andrew. The last point simply being building workflows. This is academic prototype stuff, but people who know what they're doing with building workflows could easily take the stuff we're doing and put it into some kind of workflow type system.
I mean,
So
I would just to
Great.
add on. Yeah, to add on to that, like I think Andrew specifically asked about, how you would integrate something like the inferential decompositions work. And I mean, I think this partially is what the approach here that we kind of moved over relatively quickly is about. And I think it applies equally to using large language models for sort of topic discovery as well, which is something Philip and I are on a paper called Topic GPT, which I definitely recommend that people look at. There's a danger in that what the language models are producing are not appropriately sensitive to the data. And to give an example of this that's a little bit artificial, but you could imagine it to be true. Let's say my language model has been trained largely on US-centric data. And it's analyzing a data set, and it's commentary from, it's public comments concerning, I don't know, government policies from that we've collected somehow out in the world, right? And you see people saying, well, I think we should, increase funding to police departments. We need more. We need more policing on our streets. Our cities are getting increasingly unsafe. And the model may say, okay, this is a topic about, more, say, conservative-leaning perspectives about increased policing. But if our data came from the UK, and anyone who's an expert in the UK, feel free to correct me on this, but from when I was living there, I was surprised at least among a kind of maybe certain kind of generation of labor-leaning, the labor-leaning electorate, increased policing was sort of a government spending issue. Therefore, it fell more on the left. And I've noticed this when having the let's just sample data and have language models propose topics or some version of that we don't have a sense of what's a flexible prior. We don't know it's still very poorly understood how much of the context you're providing, how much of the data you're providing to the language model is influencing a downstream prediction versus how much of its prior training data is influencing the prediction. And unless you're doing, step 4 here, where you are really looking at a careful sample and using just standard known statistics to compute margins of error to code up a sample, the model may just be producing things that have limited connection to the data you're providing. So I think it's tempting to say, oh, well, we gave it the language model data, therefore it's grounded. But if anyone's experimented with these retrieval augmented generation models for very simple question answering, or things like that, where it's very factual, should be extremely obvious from what's in the data, the models can still hallucinate even when you have the answer in the prompt. And it's only exacerbated in cases like this where there's some sort of abstractive reasoning going on. So just another reason why it's good to have sort of humans in the loop here.
In the loop. Yeah, thank you so much. I feel a lot of this is all about the central question of how do we get accurate, reliable, trustworthy results? And there were lots of questions, and I try to wrap them all into one, which might work because they're also all concerned about this. So if you are an end user, if you have obligations to ensure those accurate, reliable, and trustworthy results, what kind of guidance would you give them? And there are some questions here which point towards some issues or some things you can vary. So, for example, do you have like a best performing LLM that you would recommend? Do you have any recommendations regarding positive and negative examples versus going zero-shot learning? So any final words to our audience with guidance, or do we have to wait for the final paper here?
Well, yeah, we might have to follow up. I know after the thing with Carol, she did a whole separate video on questions. I don't know if that's necessary here, but one thing I'll say on positive, negative examples and zero versus few shot is you have to be really careful to make sure that if you do give it examples, it's not in some sense overfitting to the examples. That's a problem that I think we've seen sometimes. And so starting with few shot may not be zero shot may not be the worst thing in the world.
I was going to make the opposite recommendation, which is don't ever do. I think if you can avoid doing zero shot, unless you've done careful validation, don't do zero shot. Yeah.
I'm sorry. The unless you've done careful validation is actually
But I would say in almost no cases. I'm trying to think if there are any cases where I would recommend doing zero shot, and I think the answer is no.
I'm going to defer to Alexander as the person who has more boots.
Not to disagree too much. There may be some that I'm not thinking of, but for the things we've been talking about, I don't think there's ever been an instance where we've found that having zero shot was sort of preferable.
Yeah, but this gets back to the other question.
True.
Yeah, this gets back to the bigger question you were asking, Kara, in a way, right? Somewhere in there, Alexander, one of these slides said, validate, 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 right? And that's the thing, right? Breaking your process up so that at individual stages, you can be getting a sense of that's when it's not LLMs, but in the TopCat thing, you're going on a topic by topic basis. So in some sense, you're not just looking at the overall thing, right? You're looking at each individual one and forming judgments, being able to break things down into those smaller pieces, rather than saying, here's the question, here's the answer, right? I think that's an important piece of this process. Another thing, another thing and I'll wrap up. Another thing to think about there is you cannot rely on large language models to point back to where they, what data did you use to draw this conclusion? You saw that with a lawyer, right? You can't ask these things, but you can construct your workflow in such a way that you're giving it pieces. And so for any individual thing, you can do bookkeeping to trace things back to where they came from. Again, inspired by the topic modeling piece, right? You're breaking things down into smaller pieces. So those are some initial thoughts, but we as a community are really at the beginning trying to get the validity and rigor into the process with LLMs.
We are at the beginning, but we are unfortunately at the end of our hour here. I want to thank you all three of you, Alexander, Philip, and Andrew, for your insightful comments, thoughts, this discussion here. Again, a little plug for Andrew's continued discussion about AI in the survey context at APA. And another plug here for us, I was wrong earlier when I said this is the last one. There is actually one more, May 7th. We have one more SoDa Seed Grant Series Symposium, do county demographics shape exposure to cyber harm. Very exciting research work being done there, and I'll invite you all to join us on Tuesday, May 7th at noon. So thank you all again, and thank you, Kara, for hosting and moderating with me here today. Bye, everybody.
Thanks so much.